Wow, we already have a viewer. That's really weird. That viewer is going to disappear, though. That's like the free viewer that Google gives you to make you feel like you're
Do they
not.
really do that,
No,
you think?
I don't know.
Oh, okay.
It's just like it was weird that there was already a viewer before I even clicked turn this on. So
Well, it's probably autoplay. They were probably on a page that has autoplay.
yeah. Oh, right. Okay, sure. So did you see The Martian yet?
No.
Oh, I should put on better headphones.
Yes, you should.
Yeah, but you didn't see it. Oh, okay. So
Not
we all
yet.
went. We all went on Friday night. It was fantastic.
I had house guests and we played in the real world.
I don't understand. What is this real world that you speak of?
It's a place that includes you have massive echo now. That includes incredible slides and climbing equipment, and I now have bruises that I can't explain.
See, our viewer has gone away now.
Oh, sadness.
I have massive echo.
Yeah.
Man, okay. See, now when we turn on the recording and we go live with the broadcast, people get a chance to even see more of the sausage factory.
And I apparently need to like lock my door because the dog has figured out the door because it's cold now. Hold on.
Oh, poor dog. So anyway, if you're wondering what on earth it is that you've stumbled into here, this is going to be a live episode of Astronomy Cast, episode 386. We're going to be talking about orbiting observational observatories, observing the observable. In addition, we're actually going to do 2 episodes. So we've got that's 386, and then we're going to stop this hangout. And we'll start the next one, episode 387, which is going to be, I don't know, some kind of nonsense. Hold on. What are we talking about?
Water on Mars.
Water on Mars. That's right. Yeah, whatever. Water on Mars again. Here's a question. You as the viewer, and especially you, the kind of core Weekly Space Hangout Astronomy Cast crew folks, would you prefer that you just had 5 minutes of just blank screen, or do you actually like to see us sort of behind the scenes yakking about stuff as we get ready? I'd love to know what you think. Just post your comments into the Q&A. Not that I can necessarily deliver what it is that you want, because we've had some technical issues with Google Hangouts, and now I'm paranoid. We don't do the muting thing anymore. We just go straight with the we just go right into the show. I don't know. I kind of like the preamble. It sort of shows that we're human beings and not the robots that everyone just assumes us to be. But
I don't think anyone assumes we're robots. They see the mistakes we make.
That's true. But anyway, this is a live episode. So we are actually recording right now as you're watching it. And we would be glad to interact with you, our audience. All you have to do is just use the Q&A app. Wherever you're watching this, that says that we're interacting with the audience, click that. Screens will come up. You know how this goes. Things happen. Go ahead and post a question or a comment. And I'm going to say hello to Thomas Traniker, Guido Bibra, Stephen Walker, Ilad Avron, Korea the Vegan, Michael Dalmer, Hug Bearcog, Tony Lynch, Sylvan Westby, and I already said Guido Bibra, didn't I? Okay. That's if you say hello twice or say something twice, then I just my brain falls apart. Anyway. So you didn't see The Martian yet?
No,
I sure failure. Did. Yes, you are. There's really no way to really let you off the hook on this one.
Well, so I was doing outreach Friday night at the local museum. Saturday, I went to the city museum and played in real life all day, and then I literally slept and did email all day yesterday. So I had real life adventures that weren't in a movie theater.
Yeah, I don't understand. It was a great movie. It was a fantastic movie. You should have seen it. You let us all down.
I will go see it.
Okay, good. It was literally the best possible situation. They took a beloved book, gave it to a fantastic director, Ridley Scott, put in a serviceably snarky actor, with Matt Damon, and the special effects were great, and the themes were great, and everybody, all the other cast was great too. So I couldn't have been happier. There's a few things that were in the book that they cut out, which I wish they had left in there, just because they're so amazing. So, they really only had time to throw in a fraction of the horrible, horrible things that happened to Mark Watney. And if they had put some of the most interesting, like, how is he even going to figure this out ways, I really wish they'd been left in there. But apart from that, I couldn't have asked for a better movie. So unless it was like an extra half hour longer, would have been better, I guess. That's what I'm saying. But,
I'm trying to find the exact. There it is. So I saw this hilarious quote on Twitter the other day. Like so many things on Twitter, I have no idea who the originator is. But between Saving Private Ryan, Interstellar, and The Martian, America has spent bazillions of dollars rescuing Matt Damon.
Yeah. Well, in two of them, it was worth it. One of them, they should have just left him there.
It's true.
But I won't tell you which one was which. Yeah, that's awesome. So let's do this thing that we call an episode of Astronomy Cast.
Okay. And wait, just to be clear, which one are we starting with? Probes. We're starting with probes.
No, we're 386. The topic you chose was orbiting observers.
Yeah, those are probes. That's another name for them.
Okay. All right.
Okay. I'm ready
not to be confused with the aliens' preferred method of communication.
Yeah, we're not talking about that.
Okay.
We're safe for children.
All right. Let us begin this thing we like to call Astronomy Cast.
I'm pressing record. Hi, Preston.
I'm also pressing record. Pressing record for Preston. All right. Here comes this thing we call Astronomy Cast. Astronomy Cast, episode 386, Orbiting Observers. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing? I'm
doing well. How are you doing, Fraser?
Good. And by the time you are listening to this, Pamela and I will be together in person in Ohio, in Columbus, Ohio, participating in a series of science outreach with a bunch of our friends. As one does. So
with an astronaut.
I know, right? So look forward to a bunch of stuff we're going to try and do live on location for you guys when we get a chance to hang out together and do some shows and answer some questions. So that'll be coming up in the feed.
And we will put all of the live stream links out on the CosmoQuest Astronomy Cast and our personal Twitters. Fraser is at FCain. I am at Starstrider with a Y.
Also, I've seen The Martian. It was really good. You should also see it in case you needed that permission. I give you permission. It's fantastic. Thank you. All right, let's move on to this episode. The atmosphere keeps us alive and breathing, but it really sucks for astronomy. Fortunately, humanity has built and launched space telescopes that get above the pesky atmosphere where the skies are really clear. Let's take a look at the past, current, and future of orbital observation, aka probes. All right, Pamela, you picked this topic. Where are you going? What is this about?
Well,
these orbital observers of which you speak.
So we're currently in mission selection season, and anyone who tuned in to the weekly Space Hangout last week saw that we were talking about the down select that just happened that narrowed the field of possible missions down to 2 potential Venus spacecraft, 1 potentially going to a Trojan asteroid, a whole bunch of different interesting, fairly inner solar system ideas. And this got me thinking, we haven't really done a good roundup of all that stuff that's out in the solar system, currently sending us back, a whole lot of data.
And I think also just I mean, in addition to the round of like, which spacecraft are where and what spacecraft were where and which spacecraft are going to be where, but what are the things that they need to really think about when they're planning these kinds of missions? What are the parameters? Because in fact, a big one came up with this selection process, the sort of lack of plutonium for powering these probes into the outer solar system. And that's one of the reasons why everything that's potentially going to be targeted is going to be for the inner solar system. So there's a lot of sort of requirements that we should also talk a bit about. But where do you want to start?
Well, probably a good place to start is what's out there right now. So what's in our sky tonight, I guess. And by sky, I mean it might be on the other side of the sun, but it's out there somewhere.
Sure. Yep.
So I think the oldest mission still out there, sending us back a ton of data, is Cassini right now. So Cassini's out there. It was launched in 1998. I didn't even have a master's degree when this mission took off. And it's really scary that that's how I apparently age date things, but it is. Yeah. Cassini took its gravity assist to get on its way all the way out to Saturn, and it's in a continuing mission, but it's in its final continuation. They are going to quite purposefully suicide it into the atmosphere of Saturn in a few more years. But hey, we've gotten a good chunk of Saturn's orbit observed up close and personal.
And Cassini was like the last of one of the great orbiting missions, right? With Galileo. I'm trying to think of any other missions that were orbiting. We had the Voyager series head off into deep space, and I guess we're still communicating with them. But Cassini was really this flagship sensor suite with a ton of amazing scientific instruments, cameras, etc. There's not a lot else out there that's as sophisticated as Cassini is.
Well, and part of that is it built on that already tried and true technology that was originally developed for the Voyager 1 and Voyager 2 missions. So we have this defined platform, known technology, just upgrade it to the modern era and set off and explore. It's always easier when you don't have to recreate the wheel.
Which sort of leads down a bit of a theory that I have, which is that I wish more of the spacecraft use that sort of reusable platform, that they use an orbiter style platform, but then they put just different science instruments and send it to a different target. But, as opposed to necessarily reinventing the wheel with each mission.
And we do see a little bit of that. It's not as much recreating the wheel as you might think right off the bat. So a good pair of examples is there's Mars Express, which is still out there, still happily doing its thing at Mars. And then you have its sister spacecraft, which is no longer doing its thing at Venus, which was Venus Express. And so between those two spacecraft, you have very similar names, and you also have very similar spacecraft. Venus Express only recently retired. It retired back in January. And one of the reasons that I think we have to give tribute to, and we push Mars spacecraft as long as possible, because they also get used as communication satellites. So we have 2001 Mars Space Odyssey, or just Odyssey, but in tribute of those classic books. It's still out there orbiting, taking not the best data, but taking data on Mars. But it's a relay satellite also, getting us data back from Curiosity and Opportunity. And had Beagle survived when it got carried there by Mars Express, it didn't survive, but it would also be relaying its data back.
And Mars Odyssey gave us some of the best evidence for the large amounts of water underneath the surface of Mars. I mean, it turned to, we really learned about these vast ice deposits on Mars. Although now, of course, we've seen, in fact, liquid water potentially flowing on the surface of Mars. But
flowing's a strong word. Seeping across. Right. I'll give you seeping.
Sure. Oozing out of the sides of some craters.
But that's the next episode. We're going to talk about that next time.
Yep. Yeah. Spoiler alert. Right. So you've clearly shifted to Mars, skipped the asteroid belt as if
Well,
there's,
I was going in chronological order, and you did.
okay, sure, let's do it.
So we had Mars Odyssey, got there in 2001. Mars Express launched 2003, arriving late that year. Opportunity rover was another 2003, this time arriving in 2004 in January. So there was this great beginning of this century. Let's just send all the things to Mars, followed by Rosetta got launched in 2004, but it just got there, so we can talk about it later. But Mars Reconnaissance Orbiter, which has the sister spacecraft Lunar Reconnaissance Orbiter, Mars Reconnaissance Orbiter, it was launched in 2005. It's still up there. It's still doing its thing. And what you see with this Mars is that era when we were planning to get astronauts there, when the budgets were a little higher and the goals and missions that we were mandated by Congress were a little loftier and a little more funded.
Right.
So as the funding has been scaled back, we've had to scale back our dreams a little bit. And we don't see launches nearly as frequently, and we don't bombard single worlds with quite so many robots anymore.
Well, it also reflects the thinking at the time, a decade ago, was that the place to look for life in the solar system was Mars, and that all of the other places were, potentially, not as likely for life. But now with the discovery of these sort of full oceans under the ice on Europa, on potentially Enceladus, maybe even Callisto, and the fact that some of this liquid water actually gets up to the surface of these worlds, there's more and more emphasis being placed on potentially sending orbiter missions to these places. So, and we'll talk a bit about that in the future.
So yeah, we had this great era of Mars, and then launching things all over the rest of the solar system with the 2004 launch of Rosetta, which has finally arrived several months ago at 67P Churyumov-Gerasimenko, or Chirigiri is pronounceable. And then New Horizons took off in 2006. So there was this whole, let's just go all the places. 2007, we launched Dawn, which went to Vesta and then Ceres. And now we're in the era of seeing other nations start to fill in the science that we're not still building space probes for. And that's a kind of interesting change to get to watch.
Yeah, it's Chinese missions, Indian missions.
So we saw in 2007, America launched the Artemis mission. And then after that, it all became other countries. So you had Chang'e 2, which was the Chinese mission that went to the moon. And then this is the mission that has the most awesome orbital work I have seen in the inner solar system. So it arrived in the moon in October 2010. And then from there, it went to a Lagrange point. Then it went to an asteroid, 4179 Titanus. And then it decided, hey, I'm going to go get myself in heliocentric orbit instead. And so now it's out there in heliocentric orbit.
And that's it, though.
Well, yeah, but that's still kind of awesome for one little spacecraft.
Yeah, absolutely. So is that the sort of the full suite of spacecraft that are currently orbiting or buzzing around objects right now?
There's a few more, but we tend to forget about them because they don't produce cool pictures and they're not their nation's first big ones. So I'm going to destroy the pronunciation of this. You may know how to pronounce it better. Mangalyaan, the Indian probe that is at Mars and has sent back some pretty cool images.
We just call it MOM.
That works.
Yeah.
Okay.
Yeah. The Mars orbiter mission. But yeah.
So it's there showing that India does have interplanetary capacity. It's not the highest resolution mission out there, but it is really a test bed for what this new exploring nation is capable of. Chang'e 1 and 2 have been followed up by Chang'e 3, which was a lander on the moon. And then Chang'e 5 is also now hanging out at the moon. So China is now following our lead and covering other worlds in robots, as one does.
There's a few spacecraft that are orbiting the sun.
Well,
There's the stereo spacecraft, which are orbiting ahead and behind Earth in its orbit. And there's a bunch of stuff that's in, I guess, various Lagrange points. So, we'll skip the stuff that's actually orbiting Earth because there's like 1,300 of those. We'll talk about other stuff. And then we lost Messenger.
yeah,
Early, which is too bad. And we lost Venus Express.
right. And one of the things that doesn't get talked about nearly enough is we're slowly but surely losing our suite of Earth imaging satellites in polar orbits that are needed for weather. So we have some. We just don't have as many as weather forecasters might like. And so if you find that your weather forecasts aren't as good as they might have been a few years ago, it's not that our understanding of the weather isn't as good, although that is a part of it. Our planet is undergoing radical change and it's hard to keep the models up to date.
Right, as we're Venus forming Earth.
Yeah, exactly. Venusian forming, is that maybe how you put it?
Yeah.
But we just also don't have the full suite of satellites.
So we've talked a bit about what's out there right now, but I think what people are going to be very interested in is what's coming. And I think, the new selection of missions is a great time to talk about some of the kinds of spacecraft that are coming out. But we should talk about them, and let's also talk about the Europa mission, which has been, is pretty well and truly selected at this point.
So I have to admit, this is where, for me, spacecraft are dead until they have first light, or at least unborn, I guess is a good way to put it. I had a spacecraft I needed for my dissertation fail to function, and since then I've been a little overly cautious, you might say, and
it's like the terrestrial planet finder.
Yeah. All of these things, we get our hopes and aspirations pinned upon, and then it doesn't happen.
So do they even exist for you when they've been launched?
They do. Once they've been launched, once they're on their way. So Juno, totally alive to me. I believe in Juno. But the Europa probe, part of me is like, Congress can still kill it.
Mm-hmm.
So we do have to be cautious and careful.
All right, fine. So let's talk a bit about what is sort of the overall philosophy that's driving planetary exploration, especially the orbiters and probes into the future. And so there was a selection process that just happened. What are some of the priorities that the scientists are dealing with?
So we have a twofold issue that we're dealing with. One is the mandates that we have coming down from Congress and the president. Then the other, and that includes the fact that plutonium keeps not getting created. That's kind of a congressional decision. And then the other is we set priorities using the decadal surveys, and it's starting to get to be time to start thinking about doing a new decadal survey, but we are still going on the priorities of the last one. And some of our priorities are to start to understand those icy worlds in the outer solar system. And this is where we start looking at how do we get to Europa. This is where we have successfully looked to push the Juno mission forward. Then we also start looking at so from Congress and the president, we have this vision of Moon, asteroid, Mars as places of exploration, potential commercial venues. So you see in the mission selections, let's keep looking at ways to keep exploring asteroids. We have the OSIRIS-REx mission with its sample return to Bennu coming up in the coming years. That mission is well under construction.
But that doesn't count, right? spacecraft under construction can get canceled too.
It's true. That one's more real to me because I do get funded as part of OSIRIS-REx, so disclosure, I guess.
Right.
So when you have money from it, it makes it a little bit more real than when you're simply hoping on it. But there's also always that question of where don't we have any modern data? And Venus is definitely one of those places where we don't have modern data. The Magellan probes the Magellan probe back in the 90s, side radar, great job getting us maps of its mysterious surface. But technology is better. Maybe now we can figure out how to get something that lives a little bit longer on the surface. Maybe we can get a little bit deeper down into the clouds using balloons or other technologies. And this is where we're starting to figure out, how do we get back to Venus and we'll get a little bit more data on this planet we're not hopefully going to actually turn our planet into. But let's face it, understanding its greenhouse will certainly help us understand our own world.
Yeah, I mean, you see the pictures that came back from the Venera probes when they landed those on the surface of Venus, and they lasted for like, I think the longest was like just under an hour, and then they all died. So it would be great to have something that could last a little longer, maybe stay up in the cloud tops, use ground penetrating radar. That would all be terrific. Let's do that. So what is what is the big scientific emphasis right now, though? Are you saying it's like looking for places that we haven't seen yet, or is there sort of a theme to what, are people looking for liquid water? Are they looking for evidence of extraplanetary life? What are scientists really looking for?
So there's the follow the water, which I think is actually happening in all of the different space agencies. With NASA, we definitely have the Journey to Mars hashtag going out, and it's not just a hashtag, it's actually kind of an ideal. Let's go there, let's get the rovers following the story of the water. Curiosity is out there doing one set of experiments. The Mars 2020 rover is going to land in as different an area as possible. So Curiosity is in Gale Crater, where it can explore a very old part of Mars that potentially had water in the past. With Mars 2020, they're looking to select a site that is undergoing constant erosion, revealing the surface over, and basically it's just like when you go fossil hunting. You want to go somewhere where the cliff is crumbling down. Well, we're going to go look to see where the sand dunes are blowing the ground away, revealing potential organics, potential, may we say, fossils from the past, allowing us to understand what the past on Mars was like.
Based on all of the evidence that's come out recently, the new close-up images that Rosetta has taken of 67P, the new images of Ceres, the new images from Pluto, from New Horizons, where would you like more orbiters sent?
I have to admit, the more orbiters is something that on the inner solar system, I'm pretty good with the suite of orbiters we have. Venus, it needs something up above to linger longer because its surface is kind of death. But for the inner solar system, where we don't need the radioactive isotopes, I want to go figure out what the heck that white stuff on Ceres is. And like many others, I'm deeply concerned that we won't get a definitive answer from an orbiter. We need to go land, take a sample, and do robotic equivalent of lick the rock. Is it salt? Is it ice? We don't know. And can we find out with that spacecraft? We don't yet know. I want to know, what is that weird mountain on Ceres? And so I think it's time for us to take the idea of Philae, execute it with harpoons that don't have to live in deep space for quite so long, and go stab ourselves into the surface of more worlds and see what's there to be sampled. And so I want to see more and more. Let's go stab rocks.
I mean, there are some pretty intriguing, some of the concepts that were recently chosen. Like, one was to send a spacecraft to a metal asteroid, which would be pretty fascinating, because that's a kind of world that we've never really explored. Although I wonder what it would be like to try and stab your harpoons into into metal.
Yeah, I think there you're going to look. Can we magnet ourselves
Yeah,
too? I don't know.
yeah, that's a good idea. Um, right. So you talked about series. I mean, are there some mysteries? I mean, I would love to see some. I would like to see that Europa mission.
And
Orbiting Europa.
that starts to get to the we need the more plutonium, and we still know almost nothing about Neptune and Uranus, and we need to have orbiters on these worlds. Well, not on, but around these worlds. And as we enter the era of commercial space, it's going to be awesome to watch companies like Planetary Resources start to solve the problems of how do you move asteroids? How do you land on little itty bitty tiny things? Can we actually burrow through them the way we'd like and the way science fiction authors have been talking for, well, generations? Those things are going to start to happen in the next couple of decades, and we'll hopefully be around to report on them.
What's a place that you talked a bit about Venus for sure, that we don't have a lot of information about Venus. What are some other places that we just don't know really anything about, that we really should get a spacecraft there? I've heard Emily Lakdawalla call for a probe to Uranus, mostly because she likes to say probe to Uranus, but I think she does feel like there's some pretty good science there to be exploring some of the ice giants.
I think we definitely need to go to Uranus or Neptune. I think there's also a lot of good cases for going to Neptune so that we can also study its moon Triton, and get this comparison between Pluto and Triton. But it gets so hard to narrow things down right now, because the question is, what is it that you want to learn? Are you looking to try and pioneer manned space exploration? Well, if that's what you're looking to do, asteroids and Mars and the moon is where it's at. We need to figure out how to dig. We need to figure out how to safely get in and out of those caves on the moon and Mars. If it's pure science, if it's the search for life, we need to be going out to Titan and Europa and Enceladus and all of these worlds where we see different chemical reactions, not entirely alien to the idea of life.
And I think there's a lot of questions that a lot of regular people might not think are super interesting, but to scientists, they're really core. What did the early formation, how did the solar system form? What did it look like in its earliest times? How did things change over time? What are some of the processes, the geologic processes that are happening on these worlds? They have nothing to do with life. They're really just fundamentally understanding how our solar system came to be and how it's been changing over time. And, a lot of the kinds of instruments on these spacecraft are designed to answer those kinds of questions.
And it's really kind of amazing to think how far we've come. When we were in, I think, about fourth grade in '84, you may have been a grade or two ahead of that. When Halley's Comet first came through, that was when we first tried sending spacecraft to a comet, and they got nowhere near Halley compared to like what Rosetta is doing today. So in our lifetime, we've seen advancement after advancement, and it's today that we're now looking to okay, how do we start harvesting this ice? How do we start taking advantage of these asteroids as things we can move by our own manpower or robot power?
What do you think about the sort of ongoing advancement, both of miniaturization of the actual technology that's used in these satellites, and also the decreased launch costs that we're potentially seeing through places like SpaceX and some of the other launch providers? What impact is that going to maybe have on our ability to sense the solar system?
The big missions, unfortunately, you can only miniaturize things so much because you are limited by my lens needs to be this big, or my reflecting area needs to be this big. That's kind of defined by the rules of optics. But in terms of a lot of basic probes, we're going to first be able to get better idea of our own planet from college students launching CanSats. We're then going to slowly but surely be able to send, instead of just one big old spacecraft to Mars that we cram all the instruments on, imagine sending something that instead of dropping a rover, drops 10 very well-tested CanSats that we know will succeed. Suddenly we have a lot more students, a lot more early career researchers that are pioneering new ideas that maybe you can't quite get to via the current funding requirements.
Right. And that's sort of, it's the letting a thousand flowers bloom, right? It's this idea of getting a lot of ideas out there to test out and then take the ones that really work best and use those across the solar system. And that almost, it does feel a bit like it's sort of log jammed, you know, with just Congress having to approve this mission or that mission, and things take a long time. As you said, they take decades for these missions to come from idea to actual implementation. If we could shorten that, that would be great.
And if it takes us 30 years to test bed the technology for a major Mars mission, but 5 years to pioneer that CanSat, we'll be able to take advantage of almost modern technology for the first time ever. And for those of us who kind of lament the sad state of memory on so many of these spacecraft, we want all the data, all of it. So send so many more terabytes, send so much more powerful antenna to just get everything back, not in years, but maybe in days. Wouldn't that be awesome?
Absolutely. It would be, that I think is going to be the big revolution, is just getting these smaller, less expensive, more specific, you know, satellites to a lot of places. And I think hopefully if people can figure that out, we're going to get a lot of really interesting data. Although it's probably just going to be a million more questions that's then going to require new spacecraft to try and even answer those questions. I mean, just these white spots on Ceres alone is, as you said, that's a mission. That's a question.
Drives me crazy. Not
how could a spacecraft have gone to Ceres, found something so unusual, and not been able to provide enough of an answer that people could know what's going on there?
And satellites beget information that begets the need for new satellites. So it really is space probes all the way down.
That's exactly what it is.
And
well, that's a good place to stop.
That it is, and onward and upward into the future, I guess.
Awesome. All right. Well, thanks, Pamela.
Thank you. And stop the recording.
All right.
Okay, so we're about to confuse all of you, and we deeply apologize. If you follow us on any of the social media, we are about to send out the new link. We're going to, in order to keep our YouTube channel fairly clean, we are going to stop this recording and start a new one for our second recording of today, which is on how we have once again found water on Mars.
Before we make that switch, there's just a couple of questions I'd like to pull out before, so we don't lose them.
Okay.
So Ed Thompson says, speaking of funding, congratulations on the grant for CosmoQuest. What do you see in the future of your program? So
currently all I know is what the press release said. And I have our panel reviews, which were really good. We still don't know how much money we're getting. It could be anywhere from $1 to a whole lot of dollars. And until we know exactly how much money we're going to be getting, all I can say is all of our servers are turned on, and I have a job for 5 years, which is more than I knew last week. So it's an awesome place to be, but also one that is very vague.
Scott Jones asks, oh no, wait. And now this stupid program. John Marcello asks, sounds like the outer solar system is going dark soon. Are there any upcoming decisions on proposed flagship missions? For example, one to Uranus?
No.
And there's no plutonium and no plans for plutonium.
Well, and there's not really plans for flagship missions either.
Yeah. And Sylvan Westby notes, wouldn't it be wiser to set up a mission to the ice giants until the next generation of propulsion becomes available? I don't know about that. Like he says, it
That
doesn't
might be
lead
an
to a
awful
waiting
lot.
dilemma where each generation of probes would overtake the last. But no, I mean,
No.
you're not going to be able to go much faster, even with advanced propulsion. Like it's really just letting your momentum and a few gravity assists do the trick for you, right?
Yeah.
Tom Nathy suggests atmospheric balloon sensors for Venus and Mars with nanoprobes to go down into interesting areas for samples testing and then to die horribly.
It's the balloons aren't quite so good for Mars. Its atmosphere is just really, really thin. That's why we're having so much trouble building big parachutes. Venus, Titan, those are worlds where that's really a good answer.
Yeah. Guido Bieber is noting maybe all the interesting things will be in a director's cut of The Martian later. They're bound to have filmed a lot of additional scenes. That'd be great. I would love if that's in there. Okay. I think that's all I've got right now.
Okay.
So let's
I'm
wrap.
not seeing anything on Twitter, so.
That's right. Scott Jones wanted to know if there are any planned mission to Uranus or Neptune, and there are not. Okay, awesome. All right, so let's wrap this up. But remember, we will be back in literally
Moments.
1 minute, in moments, and so there's a link on the event pages over on Google Plus on Astronomy Cast. It's going to be episode 387. You can probably just Google search episode Astronomy Cast 387. I'll bet you it'll show up, and we'll put a link on our Twitters. So if you need somewhere else, we'll see you there in 1 minute. Thanks, everybody.
Thank you.